All right, this video is going to help you with the unit circle. And it's one of the it's a trickier part of precalculus, but we'll handle it okay. We've been kind of dipping our toe into it, kind of like trying to understand how angles and coordinates could be connected. There's a couple things I just want to remind you of is that you want to make sure that you know these two things, these two identities are going to become more and more important as time goes on. So tangent of theta equals sine over cosine, and then sine squared plus cosine squared equals 1, or sine squared of x plus cosine squared of x equals 1. So just two identities. The more you see them, the better. We kind of know that sine gets flipped to become, we kind of know that sine gets flipped to become cosecant. Let's put a little, one thing I like to do is make a little star. Then you can see where I'm talking about. So we can kind of see here that sine and cosecant are reciprocals of each other. They have a co in that pair. We can see that cosine and secant are reciprocals. You can flip one to get the other. And you can see that tangent and cotangent are reciprocals. You can flip one to get the other. So that's exciting. Okay, so let's talk a little bit about basketball, okay? So it's, if you play basketball, just kind of go with it. But we know this game around the world, and every shot is from the same distance. This shouldn't say difference. It should say distance, okay? Distance. But is every shot the same? I mean, is a baseline 3 as simple as one at the top of the key or one at an angle? You know what I'm saying? You would say the shot is kind of different. Agreed? But the distance to the basket is the same, generally. And what makes it different? I guess what makes it different is simply the angle at which you're shooting. And that affects how you're going to hit the backboard, which you could kind of consider that being like home base or the origin, right, where we're trying to get to. So we're talking about how only the angle is changing. And just like every point on this 3-point line is the same distance, every point on the circle is the same distance from the center. So if you take a circle, like the definition of it, you ever like drawn a circle with like a string? You take like a piece of string and you just kind of like go around like that and it draws a circle because they're all the same distance. So what's changing is that different points on the circle is not the distance, it's the angle, right? That's kind of the idea. So it's a little bit of a weird analogy, but I did my best. So here you have it. You can kind of see what's going on there. We can see that every place on the circle, there's different shots that you can take. They're all kind of the same shot, but in a way they're not the same shot, right? We're all the same distance from it. Okay. So here's another one, basically. So you can kind of think about this as like, if this is 0, 0, right? If this is 0, 0, what would this be? I would call this 1, 0. We went right 1 and over, and up nothing, right? But how are we going to figure out all these other points? They're going to be complicated, wouldn't you agree? Like, quite complicated. There's a couple points that are easy, but the majority of these points on this circle are going to be quite obnoxious and annoying to find. So that's what our job is today, and we'll use triangles to get there. So if that's 0, 0, right, then this would be 1, 0. So let's just talk about this for a second. This is a surprise for you, so sorry about that. Spoiler alert. If this is radius 1, okay, what other points could you draw on this circle? I know you kind of already saw them, but we kind of talked about this point being 1, 0, correct? What would be another point that you might find of interest? And let's make this big because we'll stick here for a minute. If that's 1, 0, does anybody want to jump in and tell me what else might be good? Yes, go ahead. 0, 1, which would be way up here, right? This guy? 0, 1. Good. Love it. Thank you. This is updated, but it's actually worse, it seems like. So that's great. Okay, nice. Yes, go ahead. -1, 0, another important point on the circle. -1, 0. Okay, we've started our circle. Yes, Myra. 0, -1. Very good. Okay. You probably could have got those even if you didn't see them before I erased them. So this, now you have 4 points on the unit circle, like just like that, okay? And that's really exciting. But now how do we figure out this point, right? How do we figure out this point? And the way that we're going to do it is we're going to try to figure out how high it is, which is this. That's the height of it, right? We're going to try to figure out that. We'll call that the y, or the height. That'll get us our y. And we're going to try to figure out how far over it is, which actually isn't 1. Okay, I'm going to use a different color because it's not actually 1. It's actually this right here. This is our x. And I don't know what you want to call that, your horizontal distance. I don't know. I can't call it your height. So it's how far over it is, right? So that's how we're going to figure it out. And we're going to have triangles in here to find all these points. A bajillion triangles, okay? Particularly a 30-60-90, a 45-45-90, and a 60-30-90, I guess, right? We'll flip it up. So let's kind of think about where these triangles might be. So could you imagine that like one triangle might be like this? So it's like this triangle right here. What is that triangle? It's a 45-45-90, isn't it? But this is definitely 1. This is definitely still 1, right? Now let's clutter it even more because that's what's so annoying about the unit circle. Well, let's try to figure this one out. Remember we kind of use this one a lot, pi over 6? Well, we have this triangle. What triangle is that? 30-60-90, exactly. And that same triangle, because again, visually overwhelming, but we could probably put another triangle right here. I'll use green because it's kind of the same triangle. We'd have another one here. So another 30-60-90. The angle is changed every single time, but all of these points can now be found. We can figure out what this is, and we can figure out what this is, and we can figure out what this is. Once we do figure them out, we're either going to memorize them or we're just going to get them from those triangles over and over and over. Okay? And let's just stick in quadrant 1 for today. So because the radius is 1, when you find the sine, which is opposite over hypotenuse, and the hypotenuse is 1, right? It's just opposite, right? Like straight up opposite is sine. And because the radius is 1, when you do cosine, which is adjacent over hypotenuse, but the hypotenuse is 1, it's just adjacent, right? And adjacent is the x, and opposite is the y. So that's we've kind of been building towards that. So let's kind of keep going with this. Oh yeah, love it. So this is that general idea back. So hopefully you have seen this already, just without a circle, right? All I did was add a circle here. You can see that the hypotenuse is 1. That's in green, okay? The hypotenuse is always 1 on the unit circle. It's 1 unit. The opposite is y, but y over 1 is just y. Opposite over 1 is just y. We're looking at the green, okay? I don't know why I did red here and then green there, but let's just say it's a Christmas theme or something. The blue is the adjacent, which is the x over the hypotenuse, adjacent over hypotenuse, which is x over 1. So just keep looking at it, x over 1, but x over 1 is just x. So that means that x comma y is actually, as we hopefully have already said, cosine of theta, comma, sine of theta. I think you've been prepped for that a little bit. So that is the general idea of the unit circle. Let's see if there's any more. I think there might be a little more, but I might be wrong. Let's see. Yeah, so this is kind of just the same idea, sine. So we're kind of like taking a little bit of the visual away. Let's take a look at that. This is how I did it last year. So again, adjacent over hypotenuse is the cosine. So we're looking kind of like right here. Let me get my little star out for those that are watching online in years from now. Okay. And you can see that cosine is adjacent over hypotenuse. That's actually x over 1 or a over 1. And since that's x over 1, that's just x. So the cosine is just the adjacent. The cosine is just the x. The sine is the y. So you're just going to kind of memorize this idea and just go with it. So now I'm going to ask you a kind of weird question. I'm going to ask you a question that seems kind of weird, but I'm going to ask you what is sine of 0? Okay, take a second, sit with that for a minute. What do you think sine of 0 degrees is, or 0 radians? Does anybody have any idea? what sine of 0 degrees or 0 radians is? Yes. It is? So what is the value? Well, it's not just sine. It's like, what is that point, right? So if we're doing sine of 0, we're right here, aren't we? We're right here. So we have to go by this point, which is what? What was that point? That was 1 comma 0? Which one of those is our sine? Yes? 0. Sine of 0 is 0. Let's try to draw the triangle, even though you can't because it's smashed flat. It's been smushed down, right? But let's just try to draw it. So if we tried to draw this triangle, we're going to cheat a little bit, but we're just going to go like this. Okay. Oh, that's not what I wanted. I wanted this, I think. We're going to take this, draw a nice line, flat like this, and then we're going to cheat, and we're going to draw a triangle like this that's like super, super close to 0. It's not 0, but it's super close for the visual, okay? So this here is the hypotenuse, which was in green, agreed, and it's 1. And then this here was the adjacent. If this was squished shut, what would this adjacent be? If it was squished all the way down? 1. Yeah, it'd be 1. Yeah. And if this was squished all the way down, smashed flat like a pancake, what would this be? 0. This is the triangle. It's not a triangle, clearly, obviously, right? It's not a triangle. But this is the concept. I remember being, like, quite literally, I'll share, a freshman, so 2 years older than you guys, at WPI, learning this. I learned it in pre-calc, but I had to relearn it again when I was in Calculus 1 at WPI, and they were flying. My friend there, Chris Kingsley from Texas, God bless his soul, he had already taken AP Calculus. So I had to drive him to Dunkin' Donuts so he would teach me how to do the math, okay? And I remember quite specifically understanding this idea. I mean, I think I had memorized it. So it's a smashed closed triangle. So if sine of 0 is 0, what is sine of 90? Again, I can't draw a triangle for that. But it's up here, right? It's up here. So what does our definition tell us? This is 0 comma 1. So what's sine of 90? Yeah, it is. Sine of 90 is 1. So that's where we're kind of going with this. We're going to have some triangles, and we're going to basically use them. We're going to put them inside of this circle. We're going to focus on quadrant 1, and eventually we might do more with that. But for right now, we're okay. So see, again, this is a couple of different values that we can kind of talk about. So sine of pi over 2 is 1. That's 90. Cosine of pi over 2 is 0. So all of these points that you guys gave me on the circle, they're called actually quadrantal because they're on an axis. And typically they're 0 or 1 or negative 1. Sometimes they're undefined, but not today, in the future. So that's pretty much where we're at. That is basically the unit circle. We did our best to kind of like make it digestible, I guess. And then we'll talk about this one more time. So let's just talk about one of the triangles that's possibly inside of there. They're the special right triangles because they're so special. They're really special to us. So we take it, we draw a 30, 60, 90, or a pi over 3, pi over 2, pi over 6. Although those are in the wrong order. And then we can figure out what's going on here. Now, it's a little weird because the special right triangle that you learned, it actually looked like this, didn't it? And it had a 2 here and a 1 here and a root 3 over 2. What was this? Was this root 3, right? Yeah. But this is not the right size triangle, correct? Isn't this triangle too big? Because isn't the hypotenuse 2, and shouldn't the hypotenuse be 1? Well, what are we going to have to do? We're going to have to scale it down, right? So we're going to have to take this and divide everything by 2 to get that radius of 1 that we wanted. And that gives us the triangle in purple, which is 1 for the hypotenuse, root 3 over 2, and 1/2. So we took our special right triangle, which is in black, divided it by the green, because it was twice the size of that one. Right? And maybe I should make it twice the size, quite literally, so it like makes a little bit more sense. It lands better. So because it was twice the size of it, and I'll try to make it twice the size-ish. Because it was twice the size, we had to scale that triangle down to make it fit in the circle. And we get these values. So what is sine of 60? I mean, we kind of did it earlier, right? But what is sine of 60? So sine of 60, which is pi over 3, right? Which is pi over 3, must be the y value, must be root 3 over 2. And you could use the black triangle to get there too, right? You don't have to scale it down by the green. Root 3 over 2 also comes from this. So you can still use the big triangle throughout your whole experience, because similar triangles, it's all going to come out the same. Okay. All right, that's a pretty good introduction to it. This is a circle with radius 1. We can kind of see what's happening here. As you can see, it's visually overwhelming. There's that diagram I showed you where it's like a pancake triangle, right? We can remember that the x is cosine, the y is sine. We can see that we can find some of these different values. We can kind of see, let's go through a couple of them one at a time. So I'll use a highlighter. Sine of pi is 0. Why is that? Because sine of pi is the y value up here. Oops, sorry. Sine of pi is actually the y value over here. So that's this. When I go to pi, which is all the way around, I wrap around to negative 1, 0, the red point on the left, and the y value is 0. Cosine of pi over 2, that's up top here. So cosine of pi over 2, so when I go to pi over 2 for my cosine, I get 0. And that's because that's our x value at pi over 2. Sine of 3 pi over 2 is this purple line down here. Okay, I'll use magenta. 3 pi over 2, our sine, and that's going to be our y value from down here. Sine of 0 is 0, because as you can kind of see over here, that when sine is 0, you're at a y value of 0. And lastly, we'll use a crayon. Sound good to you? Let's use a crayon. Let's use a purple crayon. Right here. It's actually a crayon. Cosine of 0 is the x value, and so that's 1. How's that? Let's do a little thumbs up, thumbs down, thumbs sideways, because there's a lot going on there. Okay, that's pretty good. Pretty good, actually. That is pretty solid. I wouldn't be expecting 1,000 thumbs up there. Okay, so this is on video, so you can always go back to it. That's a really cool thing about it. So now let's talk about how this really works in a more practical, or just kind of just doing it. You know what I mean? So the person that made the packet is kind of more like, here's how you do it. This is the answer. You know, and I don't love that, but I understand it has a place. We're looking at how many minutes here? 18. So I got to stop. I'll probably make another video because this is a big day.